whenever you're ready.
So here's our presentation on experimentation on the human genome. When researching, we looked at these two questions mainly. Should it be allowed, and what restrictions will ensure that it is safe? So to start off, human genome editing is a scientific process that includes altering, replacing, and adding or removing genetic materials in human DNA. And there are many different methods, but the most recent one is CRISPR. Since it's new, there's lots of unknowns, and there's room for mistakes, like the editing tools could cut in the wrong place, and scientists don't know what the effect of this would be yet. Also, there's concerns that have come up about cancer-fighting cells losing their abilities to fight after using CRISPR. But CRISPR is faster, more efficient, and cheaper than the other methods. Oh my god. And also another concern
Ryan, did you get that? Thank you.
is that mental health issues could arise if people use it to create perfect or ideal babies. There are successful stories with the use of human genome editing already. First is Layla. She was a 1-year-old in the UK, and she was fighting leukemia. They tried many different treatments, but none of them worked, so they got special permission to treat her with a method called talons. It saved her life, and it also saved her family from the pain of losing a child. Two other successful stories are using CRISPR treatments. The two patients had sickle cell anemia and beta thalassemia. And this is the first clinical evidence of CRISPR that ended with success. Other diseases it can treat are Alzheimer's, cystic fibrosis, heart disease, and blood disorders. In 2018, there was a survey done with adults in the US on their opinions of editing the human genome and what is appropriate to use it for. 72% said it's okay to treat diseases that babies will be born with. 60% think it is acceptable to use to prevent diseases babies may have later in life. But 80% do not think it is okay to use it to make more intelligent children, and they think that is taking science too far. I do think the benefits outweigh the risks, but restrictions are definitely necessary, especially since the technology is still so new, and there's so many unknowns. So it should be used for medical purposes and not changing looks or intelligence.
So from an ethical standpoint, when we're talking about the ethics of human gene editing, what we're mainly referring to is we want to make sure that the technology is safe for everybody. Nobody's being put in danger. And not only the people who are receiving the technology, like the patients, but also the future generations. So we want to make sure that there's no unintended implications of editing one person's genome that their offspring and future generations will have. So we'll talk about that later in the next slide. But another thing that we want to make sure is that no person's safety should be sacrificed for the gain of scientific knowledge, because that is completely unethical to sacrifice somebody's life for just the basic gain of knowledge, which can be probably done through other ways, which is also something we're going to talk about in a little bit. So gene drives are modified genes that don't follow typical heredity rules, as shown by this graphic. So a gene drive is a gene that has a tipped probability for that gene to be passed down to future generations. So basically, that gene is modified so that it is driven through the population. And sometimes this is a good thing. For example, a malaria-carrying population of mosquitoes was intentionally injected with a gene drive that caused the entire population to be eliminated. We can't do this on a large scale because of the environmental and ecological effects, but it's a very good symbol for what is possible with it. Although it's a good thing in this case, it's not always beneficial. For example, in human gene editing, a gene drive may be accidentally created. And for example, if this gene drive creates antibiotic resistance in humans, it could be detrimental. Several generations down, everybody would have antibiotic resistance. Most, if not all of us, have used antibiotics at some point to treat some sort of illness. And with antibiotic resistance, we wouldn't be able to do that, and we would have to find other treatments or methods to go around that. So essentially, what could happen is we think that we're editing one letter of the Book of Life, but in actuality, we're changing entire pages. And these pages could be changed in completely unintended areas. So the long-term danger isn't necessarily in the immediate effects of the patient receiving gene editing, but the changes to the organism that they carry on to future generations and their direct offspring. So another thing that we want to talk about concerning the ethics is the twin girls experiment. So Dr. Tjrl's experimentation is a good example of changing entire pages in unintended areas. So his experimentation with two twin girls, removing the CCR5 gene, which allows HIV to be transmitted in cells, is largely viewed as completely unethical for several reasons, including the flawed informed consent process, the fact that he endangered the lives of the twins, and the little scientific benefit that followed. So he removed the CCR5 gene, which may have reduced their susceptibility to HIV, but he also increased their susceptibility to West Nile virus in Japanese encephalitis. So by knocking down one head of the Hydra, he sprouted two more. And arguably one of the most unethical parts about it is that if needed, if the girls ever did need HIV prevention, that there are already drugs available that can remove the CCR5 gene, and that gene editing was a completely unnecessary way to go about solving a problem that didn't even exist. So our conclusion is basically that gene editing is great. There is so much potential, and the benefits certainly outweigh the risks. There are many diseases and conditions that can be cured with the help of gene manipulation, but the appropriate uses must be determined by a combination of the public, experts in the field, and government leaders. As well as this, it should only be used when absolutely necessary. In the case of the CCR5 gene, gene editing was not the proper way to go about fixing it. And if the twin girls ever did need to remove the CCR5 gene because of HIV susceptibility, then they could do that with the drugs and only have to rely on gene manipulation as sort of a last resort. And lastly, is that we must be sure with full certainty that gene editing will not create a gene drive in an unintended area of our genome that will go on and affect future generations. And this could cause some things as extreme as, for example, antibiotic resistance, or maybe increased susceptibility to influenza. Most of us have probably had the flu at some point. So if we have increased susceptibility, then that goes very, very long term, and we could see a possible influx of the death from influenza if something like that were to happen. So all in all, gene editing is very, very beneficial to society, and it's got a lot of potential, but we just need to make sure that it's 100% safe and that no people or the future generations following will have unintended effects.
Okay, thank you, Ryan and Tjrl. Hey, Tjrl, do you have one specific way that your thinking changed as a result of learning about Ryan's findings?
Well, me and Ryan both looked at the twin girls experiment, but I looked at it from a scientific perspective. So looking at it the way he researched it from his lens, I was able to learn more and see that they actually do both connect.
Okay, all right. Ryan, having finished the project now, what, if anything, would you consider to be a gap in the research that you did that if you addressed it would make you feel more confident about your conclusion?
I feel like in our presentation we addressed some of the implications that could happen if gene editing is left uncontrolled. For example, gene drives and the experiment with the twin girls resulted in like unintended effects with susceptibility to other viruses. So we considered that, but one thing that we didn't really take on was we never assumed the viewpoint of somebody who opposes gene editing. We never assumed, well, what if somebody feels like they have a religious or moral obligation to not follow gene editing, and that somebody's like God-given genes and traits should be kept. We never actually considered like the direct viewpoint of somebody who is opposed to gene editing, and rather we just kind of considered some of the implications of it and how to prevent that.
Okay, thank you. Another round of applause.